Hello fam, this is Zekaya from Mathatainment, reminding you that enthusiasm implies excellence. We are still dealing with our so-called non-routine exercises under Algebra, grade 12. So the problem that we are going to look at is as follows. Here we are required to evaluate the following expression, and the expression is you have a fifth root, and underneath this fifth root, we have a square root of 35 plus 3, multiplied by another fifth root, and underneath that fifth root, you have a square root of 35 minus 3. Well, before we begin this problem, I would like us to go back to our grade 10 class. In our grade 10 class, you probably remember that when you are multiplying sets, for example, you have an nth root of some number, which we are going to call x in this case, and we are multiplying this set with another nth root of some number, which we can call y. Here, you are allowed to write these under one set, and then you write them as a product. So an nth root of x multiplied by an nth root of y is the same as nth root of xy. The special case is when you have a square root of x multiplied by a square root of y. That is the same as a square root of xy. That's just a special case of this general equation that I gave you above there. So following exactly this rule here, this is what we have looking at this. You can see that here you are multiplying two sets and they are both fifth roots. So by doing so, you are allowed to write this under one set, and then you have your fifth root, and underneath this fifth root, you are going to take the product of a square root of 35 plus 3 and a square root of 35 minus 3. So we are writing the quantity underneath the square root as a product under one set now. And again, if you can remember in grade 10 again, when you have an expression that is written in this factorized form, you have x plus y, x minus y. In grade 10, we used to call this x squared minus y squared, and it has a special name. The special name that we call this a difference of two squares. We call this a difference of two squares. So I bet you do recognize that we have a difference of two squares underneath that fifth root. So we are going to follow that. That's why here I'm going to have my fifth root, and underneath this fifth root, having a difference of two squares, it means I need to have a square root of 35 all squared minus 3 squared. And my following step will be a fifth root, and underneath the fifth root, a square root of 35 all squared. That squared there frees the 35 under the square root. So now you have your 35 like that, and then 35 minus 3 squared. 3 squared is 9, so you have 35 minus 9. That's why here you have a fifth root of 35 minus 9. 35 minus 9 is 26. So this is your answer here, because remember, we are not required to use a calculator for such problems here. The assumption is that you don't even have your calculator at your hand, but I firmly believe that a mathematician does not depend on a calculator. So you are allowed to stop there. You have a fifth root of 26. We have simplified sufficiently. Okay, so this is the kind of problem that we are faced with. In order for me to check if you understood what I was saying, I'm not leaving you guys alone, but I'm leaving you with your problem to try. You are required to try this problem and evaluate. You have a cube root, and underneath the cube root, you have a square root of 11 plus 2, multiplied by another cube root. Underneath this cube root, you have a square root of 11 minus 2. So please satisfy yourself if you can find an answer to this, if you can simplify this sufficiently. Remember, do not use a calculator. So this is where we end today's lesson on non-routine exercises. Thank you. I can't wait to see you guys on the next video.